السلام عليكم. Do you hear me? Okay. So in this virtual session we will continue with chapter number 2 about data. So the first question is, what is data? In data mining, data is a collection of data objects and their attributes. And an attribute is a property or characteristic of an object. Here in this example, this is our data. All this represent data. Okay, and this is one of the attributes. So a collection of attributes describe an object. Object is also known as record, point, case, sample, entity, or instance. So can you give me an example of an object in this data? Can you give me an example of an object? Single? No, it is not an object. Yes, very good. A row is an object. So this is an example of an object, all this. This is an object or instance. So 3, no, 3 as ID, no refund, single as marital status, and 70K as taxable income, and no as shit. This is an object. It's clear? Any questions? Yes, the whole tuple is an object. Yes, the tuple is an object. Attribute values. So attribute value are numbers or symbols assigned to an attribute. For example, here, the values of the attribute refund are yes or no. Attribute values. The values of marital status is single or married, etc. So different attributes can be mapped to the same set of values. For example, I will send you, if we will use only one textbook or 2 textbooks. يعني إلى حد الآن ما اجتمعنا مع الكوردينيتور. هبلغكم بالشيء هذا لأنه أنا الحين في الشابتر نمبر 2 شفت إنه الشابتر هذا مكتوب بطريقة أسهل. أنا هبلغكم بالديتيل هذا إيش التكست بوك اللي حنعتمده وإيش الشابتر اللي حنعتمده إن شاء الله. أوكي. طيب بس الشابتر يعني التكست بوك هذا والتكست بوك الثاني نفس الكونتنت، شابتر نمبر 2 about data، بس الطريقة المكتوبة في الشابتر هذا أسهل، لذلك اعتمدته هنا في الفيرتشوال سيشن. So different attributes can be mapped to the same set of attributes. For example, attribute values for ID and age are integers. But properties of attribute values can be different. For example, the ID has no limit, but the age has a maximum and minimum value. It's clear? This point is clear? So ID, age are integers. So different attributes can be mapped to we have the same set of values, but properties of attribute values can be different. Let's move now to types of attributes. So there are different types of attributes: nominal, ordinal, interval, and ratio. So what's the meaning of nominal type? For example, ID numbers, eye color, zip code are some examples of nominal attribute. Not numerical now. Eye color, for example, can be green, black. This is a nominal attribute. Ordinal, that means there is an order. This is an example of an ordinal attribute. There is an order. This is another example from 1 to 10. Interval is another type of attribute. Yes, that means the number of possibilities are known. Finite possibility. Here, for example, for eye color, we have two possibilities, two values, two possible values. I will describe each type here. So for nominal, the value of a nominal attribute are just different names. Just different names. Okay? For ordinal, the value of an ordinal attribute provides enough information to order object. For example, here, good, better, best. There is an order. It's clear the difference between nominal and ordinal. Okay. Interval. So for interval attribute, the differences between values are يعني عندهم معنى unit of measurement exists. For example, calendar dates is an example of interval. أو درجة الحرارة مثال آخر. يعني مثلا درجة الحرارة بين 70 و 80 10 درجات وبين 80 و 90 10 درجات. We talk about interval attribute. And ratio, for ratio variable, both differences and ratio has a sense. So there are some examples of ratio attribute. Let's move now to discrete and continuous attribute. So discrete attribute has only a finite. وعليكم السلام ورحمة الله وبركاته. A finite or countably infinite set of values. For example, zip codes or counts of the set of words in a collection of documents. So there is a finite set of values, often represented as an integer variables. For example, binary attributes are a special case of discrete attributes. Why? So why binary attributes are a special case of discrete attributes? Yes, because binary attributes can have 0 or 1, limited. Very good. So there is a finite set of values. So discrete, that means there is a number, a finite number. So for example, I give you an example. Length, (100), 200, 150, 200, 100. So length here can be considered as a discrete attribute. Why? Because we have 3 possible values. It's clear for you? But if length is presented as like this, length is presented like this: 100, 05, 200, 06, 200, 07, etc. In this case, infinite possibilities. And in this case, we talk about continuous, not discrete. It's clear, Mr. Abdullah? No? Okay. So continuous attribute has real numbers as attribute values. And continuous attributes are typically represented as a floating point variables. Let's move now to types of data set. So there are 3 types of data set: record, graph, and ordered. In the record, you can find data matrix, you can find document data, you can find transaction data. In the graph, you can find the web, molecular structures. In the ordered, we can find spatial data, temporal data, sequential data, etc. So let's move to some examples of this type of data. Record data. So record data that consists of a collection of records. collection of records, and each of which consists of a fixed set of attributes. So here, how many features we have in this record data? How many features? 5, 4. Really, we have 1, 2, 3, 4, 5. 5 features, but in the data mining, this ID is not used as a feature, so we have only 4. Okay, 4: refund, marital status, taxable income, and chat. Sorry, Mr. Faisal. Features, that means when we use a record like this, what are the attributes of this record? There is 4 attributes, 4 features or 4 attributes. Any questions? It's clear for you, Mr. Faisal? Good. So keep in the mind that record data is data that consists of a collection of records, and there is a fixed set of attributes. The number of attributes is fixed. In our case, there are 4 attributes. Let's move now to data matrix, the second type. So if data objects have the same fixed set of numeric attributes, so here we have fixed set of numeric attributes, then the data objects can be as point in a multidimensional space. Here we talk about multidimensional space, which each dimension represents a distinct attribute. So this is an example of data matrix. So in this example, how many dimensions you have? How many dimensions? I repeat my question. How many dimensions we have in this example? Yes, good. 5, not 3 multiplied by 5, only 5. So here, each dimension represents a distinct attribute. So we have 1, 2, 3, 4, 5. 5 dimensions. It's clear? Okay. Any questions about data matrix? So in the data matrix, so what is the difference between record data and data matrix? So here we have a fixed set of numeric attributes. Numeric attributes. Okay? And each attribute represents a dimension. Let's move now to document data, another type of data, document data. So each document becomes a term vector, and each term is a compound or attribute of the vector. So the value of each compound is the number of times the corresponding term occurs in the document. So this is an example of document data. So can you explain me what is the meaning of 6 here? What represents 6? Yes. So that means the occurrence of the word game in document 1 is 6. The number of time. Good. So here, for example, 0, that means the document number 1, there is no word couch in document number 1. 5 here, that means, yes, the word play occurs 5 times in document number 1, etc. So here we talk about document data. It's clear, document data. Okay, so how many attributes we can find in document data? How many attributes? Okay, here we have 10, but in general, how many attributes? No, not 13, 10. Okay, 0 to many, 0 to unlimited, no. No. Without 0, 11, no. So for example, we have this document number 1, we have X, Y, Z, 3 words. Document number 2, we have X, W, Z. And document number 3, we have X, Y. So in this example, we have 3 documents. How many attributes in this example, in this document data? How many attributes when we will dress our document data? 3, 4. Good. Not 3, 4. So what are the 4 possible attributes? X, Y, Z, and W. So the number of attributes is the possible words contained in all documents. The number of possible words contained in all documents. It's clear? So here, for example, in document number 1, we have X, Y, Z, 0. Document number 2, we have X1, W1, Z1, and Y0. And document number 3, we have X1, W1, Z0, and W0. Okay, let's move now to transaction data. So it is a special type of record data where each record involves a set of items. And for example, we have the set of products purchased by a customer during a shopping trip constitute a transaction, while the individual products that were purchased are the items. So transaction data here is an example of record data, a special type of record data. So can you explain me this data set? For example, can you explain me this object, this one? Yes, the transaction data will be used after that with association to extract association rules. But here, what are the attributes? Yes, customer number 2 buy beer and bread. Good. So, and customer number 5 buy Coke, diaper, and milk. So there is a fixed number of attributes or not. So in the transaction data, we can find the transaction, the length of transaction can be variable. So the first customer gets 3 products. The second one gets only 2. The third one gets 4 products, etc. So in record data, we have a fixed number of attributes. But in the transaction data, the number of attributes is not fixed. And each record represents a ticket, represent what are the products purchased by a customer. It is clear, transaction data. Any questions? Okay. So here in the transaction data, the order is important or not? The order is important. No, very good. So the order is not important. So the second transaction we can write beer bread or bread beer is the same. Just a moment, please. Okay, let's move now to graph data. So this is an example of a graph data. It is a generic graph and HTML links. So we can create from this HTML document a graph data. And after that, we can apply graph mining. We will see how we can apply graph mining to extract knowledge from graph data. This is a chemical data. Also, we can extract knowledge from chemical data. So this one is ordered data. So can you explain me this data? This one. So here the order is important or not in this data? The order is important. Yes. So for this reason we talk about ordered data. So in this example we will get A, B, after that D, after that C, E. Okay. So this example is different if we write, for example, here, different if I write D, A, B, C, E. So the order is very important. Okay. This is another example of data. It represents the genomic sequence data. Also, spatiotemporal data. So why we say spatiotemporal here? Why we say that spatiotemporal data? Spatiotemporal data. And about location. Yes. Good. Here because so the response is data according to certain location and time. So in this example the data is هي درجة الحرارة. هذه الvalue. Every month. So month, every month represent the temporal, and of land and ocean. Land and ocean is the special. So we have spatial data and temporal data. The combination is spatiotemporal data. Data according to certain location and certain time. It's clear? So let's move now to data quality. What kinds of data quality problems? How can we detect problems with the data? What can we do about these problems? So examples of data quality problems: noise and outliers, or missing values, or duplicate data. So what's the meaning of an outlier? Outlier. Have you an idea about an outlier? Yes, too far. Good, very good. Yes, elements that outside, too far from normal values, a shed. Yes. Let's begin with noise. So noise refers to modification of origin values. Distortion of a person's voice when talking on a poor phone. This is a noisy data. So this one is the real data, but this one is plus noise. Outliers. So outliers are data objects with characteristics that are considerably different than most of the other data objects in the data set. So in this example, how many outliers we have? How many outliers? 3. Good. So this one, and this one are outliers. 3 outliers. Missing values. So what are the reasons for missing values? For example, information is not collected. People decline to give their age and weight, for example. Or attributes may not be applicable to all cases. If we demand the annual income to some children. So how we can resolve the problem of missing values? We can eliminate data objects. So if we have an object with missing values, the first solution, we can eliminate this object. Or we can also estimate missing value. How we can estimate the missing values? Have you an idea how we can estimate the missing values? Yes, an example, we can calculate the average of all values, or we can make interpolation. Yes, yes. Also, we can ignore the missing values during analysis, or replace with all possible values. So there are many solutions to resolve the problem of missing values. Any questions? Another problem, the duplicate data. So data set may include data objects that are duplicates or almost duplicates of one another. For example, a same person with multiple email addresses. So the solution is data cleaning, process of dealing with duplicate data issues. So we must eliminate duplicate data. Why? Why we must eliminate duplicate data in data mining? No, because duplicate data can be considered more important than another data. Yes, to get relevant knowledge. Yes, very good. No, it is not a problem of it is not the same problem in database. I will give you an example. So for example, if we have this example of data 1 2 5 6 1 2 5 6 1 2 5 6 3 2 1 1. So in this case we have duplicate data, and this data can be considered more important than this one. So in data mining, if we have duplicate data, we must eliminate this duplicate data. So let's move now to data pre-processing. So there are many techniques to pre-process the data. We can make aggregation, sampling, dimensionality reduction, feature subset selection, feature creation, discretization and binarization, attribute transformation, etc. So all these techniques are data pre-processing. So we must make pre-processing before retraining. So aggregation, that means combining two or more attributes into a single attribute. Why we make aggregation? The question is why? Why we make aggregation of attributes? So aggregation, that means combining two or more attributes into a single attribute. So we make aggregation to reduce data, to reduce the number of attributes, to change of scale. For example, if we say it's a city, we can use regions or states or country. And in this case, we will obtain more stable data. Yes. So the data will be more stable. This is an example of aggregation. Let's move to sampling. So sampling is the main technique employed for data selection. So when we say sampling, that means we will select some data. Data selection. We will select some data. So sampling is used in data mining because processing the entire set of data of interest is too expensive or time consuming. For example, if we want to classify websites into violent and non-violent websites, we cannot make data mining on the whole of websites in the internet, but we must choose some examples. So we say sampling, and there are many types of sampling. Have you an idea about these types? Yes, that means we will select some data. So what are the types of sampling? Random, yes, random sampling. Also another type. So type of sampling, there is simple random sampling. This is the first type. So simple random sampling. The second one is sampling without replacement. The third one, sampling with replacement. And the fourth one is stratified sampling. So there are 4 types of sampling. It's clear? Any questions about sampling? Okay. Simple random sampling. So for example, this is our example. We have 1, 2, 3, and 4. So simple random sampling, that means we will select any item, any particular item. We can select 1 or 2 or 3 or 4. And sampling without replacement, that means if we select 2, for example, after that we cannot select another time 2. So I want to select, so for example, I select 1, after that 1 must be removed from the population. We cannot select another time 1. But sampling with replacement, that means I can select one, after that I can select another time one, after that we can select another time one, etc. because one is not removed. And stratified sampling, I will split the data into several portions. For example, in two portions, this is the first portion, this is the second one, and after that we make random samples from each portion. From the portion number 1, I make a random sampling. For portion number 2, I make a random sampling, etc. Okay. Okay, so there are some techniques to the dimensionality reduction, like PCA is a technique to dimensionality reduction. Also, isomap is also a technique to dimensionality reduction. Dimensionality reduction, that means we will reduce the number of attributes. So sampling, we will select some examples, some data object, and dimensionality reduction, that means we will reduce the number of attributes. We can also select some attributes, select the relevant attributes. So in this case we talk about feature subset selection. Okay, so just I want to save the participant list. Just a moment, please. اوكي. بالنسبة للمشكلة هذا تبع التحميل، اتصلت على الدكتور حبيب قال لي انه لازم تباشروا يعني تتصلوا على البلاك بورد سيبورت، يعني راسلوا البلاك بورد سيبورت عشان تحلوا مشكلة التحميل. طيب نشوفكم الأسبوع القادم إن شاء الله في الفيس تو فيس. السلام عليكم ورحمة الله وبركاته. You are welcome.